we are going to continue to investigate rational expression. So this would be continuation from the previous lecture. All right, rational expression. So now what we are going to do is rational expression add and subtract. Add and subtract. So between rational expression, we are going to try to add, try to subtract. Just like all the other rational number addition and subtraction, what we need to have is common denominator. Right? We need to have common denominator. So if given equation is already in a common denominator form, then all you really need to do is just combine the top and the bottom. So let's do a couple of examples. Let's say we have 2x squared minus 5 over 3x minus 1 plus x plus 7 over 3x minus 1. Now, as you can see, we have the same denominator, common denominator. Well, if that's the case, what we really need to do is just simply combine these two and treat this as 2x squared minus 5 plus x plus 7, just like that. And as for the final step, just combine these two like terms. These two are the number terms. So 2x squared plus x, we're going to write the x term, minus 5 plus 7 plus 2, and 3x minus 1, just like that, right? Okay, so we also need to check what x value will make this denominator equal to 0. So let me do it in here. So when do we have 3x minus 1 become 0? Well, you just need to solve this. So 3x equal 1. You can think of this as adding 1 on both sides, or you can just simply think of this as moving this across the equal sign. Whenever that you move a term across the equal sign, their sign change. So this minus 1 become plus 1. Now divide both sides by 3. Cancel, cancel. X equal 1/3. So this x equal 1/3 is the x value which will make this equal to 0. And we do not want that to be 0. So we should say x cannot be equal to 1/3. Right? Okay. So I move. Okay. All right. Let's do another equation. Let's say x minus 3 minus 3x plus 5 x minus 3. Well, this is rational expression subtraction. You know, this is pretty straightforward as well. Since we already have common denominator, all we need to do is just simply combine that together. X, this part right there, minus. Now that's a common mistake that many students will likely to make. You need to put this into parentheses like that, because that minus applied to all that. right? All that. So you need to put that parentheses, just like this. Then this would be, then you need to apply this minus inside parentheses. That will change that to minus 3x, and they'll change that to minus 5. That x3, combine those two like terms together, x minus 3 minus 2x minus 5 over x minus 3. And of course, x cannot be equal to 3, right? If x equal to 3, then you know that denominator becomes 0. So there you go. This is what we have. So if the denominators are already in the same form, then you don't really have to worry too much. Just simply combine that together, right? Now this is similar, yet slightly different. So let's try this. Let's say we have 2x over, I don't like this writing. Let me start over. 2x over x minus 3 plus x plus 2 over 3 minus x. Now let's check this one. We try something similar to this in our previous lecture. See this denominator right here and this denominator right here. They are not exactly the same. They are in different order. They both have minus. So let me just set this one aside. 3 minus x. You can rewrite this as minus x plus 3. Remember that same trick. Now what we are going to do, we're going to factor out the x. We write this as x minus 3, like this. As you can see, if you apply this minus inside, it'll change that to minus x. It'll change that minus to plus 3. So we restore the original form. So this is what we are going to use. So now we can rewrite. The first term, we're just going to write exactly the same. But this is going to be rewritten as negative x minus 3 over x plus 2. Just like that. Now, what are we going to do with this minus there? Well, this minus, we can pull it to the front. So this first term, exactly the same. That minus, we can pull it to the front. We'll change that plus to minus, and we have x minus 3 and x plus 2, just like that. Okay. Now that we have a common denominator, x minus 3, we have 2x minus, remember the parentheses, x plus 2. Then this is going to be x minus 3 in the bottom denominator. This would be 2x minus x minus 2. Remember that will be included inside this parenthesis. It'll change these two. Okay, so our final answer, combine these two, would be x minus 2 and x minus 3 in the bottom, and x cannot be equal to 3, of course, right? Okay. So rational expression, addition, subtraction, basically almost the same thing. If we have common denominator, treat just combine the denominator and combine the numerator, just like that. Now, what if we do not have a common denominator? Then that's that's a little bit different, a little bit more complicated. So let's try a case that we do not have common denominator. So let's say we have x minus 3 over x plus 4 plus we have x over x minus 2. Let's say we have something like this. Now, as you can see, we have these two different denominator. So what we are going to do, we are going to make it as a common denominator. So I think that's a little too long. 4x minus 3 on the top and x plus 4 on the bottom. I'm talking about this first term. I'm going to multiply the top and the bottom, the other part, denominator from the other part. So I'm going to multiply x minus 2 and x minus 2, just like that. Now, because we have the same x minus on the top, we can cancel, of course. If we cancel these two, it'll be just like this one. But by doing so, we will get to the common denominator plus. Now the second part, pre-existing second part, would be x minus 2, just like that. Now the top and the bottom, we are going to multiply the other parts denominator. So we're going to multiply x plus 4 here and x plus 4 there. Now we have x plus 4, x minus 4. This has been switched. Same thing though, right? We have the common denominator. Now that we have common denominator, we can combine these two, right? We can combine these two. So now our denominator is x plus 4, x minus 2. Now this one, okay, let me write the actual step. Minus 3, x minus 2 plus x times x plus 4. Okay. Now this would be same thing as x plus 4, x minus 2. Now I'm going to expand. So this times this, x squared, that times this, 2x, this times this, minus 3x, 6 plus 6, right? Plus x times x squared, plus 4x. All right, so we've done all that. Now what we are going to do, we're going to combine the like term, right? We're going to combine the like term. So see if we can fit it in here. Denominator is the same. Now we have x squared and x squared, so it'll be 2x squared. So and that is gone. We have negative 2x, negative 3x, and plus 4x. So that's negative 5 plus 4. So that must be negative x. So that is gone. Oh, so we just have 6. 6. Just like that. Okay. So as you can see, this would be our final answer, and we also should have x cannot be equal to negative 4, x cannot be equal to 2, right? From any one of those denominator, we need to have this as well, because we don't want that the denominator goes to 0. All right, now let's try basically similar question. So let's say x squared, we have x squared minus 4 minus 1 over x. 1 over x. So same trick. A little too long. X squared and x squared minus 4. To that, we're going to multiply the other parts. X here times x there. Minus 1 over x. We're going to multiply the other parts. So it's going to be x squared minus 4 and x squared minus 4. Just like that. Alright. So now that we have a common denominator, which is x times x squared minus 4, this would be x to the third minus, let's look at this. Well, let me write it down. X squared minus 4. Just like that. Now, we can also rewrite this as x. Remember this one right here? This is actually x squared minus 2 squared. If it's 2 squared, we can factor that like this. X plus 2, x minus 2, and this on the top, x to the cube minus x plus 4, x squared, right? Square. Okay. Now, we do not want x to be equal to 0 from right here. We do not want x to be negative 2 from here. We do not want x to be 2. So this is our answer, and we also need to have this as well. Okay. Now, next example would be slightly different, almost the same but slightly different one. So let's try this example. Let's say we need to add these two rational expressions. One looks like this: x squared plus 3x plus 2. another one looks like this. 2x minus 3, and this looks like x squared minus 1. Okay, we can simply try to multiply the other parts of terms of denominator top and the bottom, right here and here, and multiply that to here and here to make it as a common denominator. That's possible. However, it'll take longer than what it has to be. So if we can actually factor it out, then you will find a shorter solution for this. So I'm trying to factor this out, and it looks like it's 2 and 1. Like that. And this is same thing as x squared minus 1 squared, right? 1 squared is still 1. So this is difference of square, x plus 1, x minus 1. Just like that. Okay, so look at this. We have x plus 2, x plus 1, and also x minus 1. So to this, let me rewrite it. We have x plus 2, x plus 1. To this, what we need to multiply is x minus 1. X minus 1, like that. And to the second term right here, which is x plus 1, x minus 1, and 2x minus 3. To this, what we need to multiply is actually that one right there, x plus 2 and x plus 2, just like that. So just by multiplying these two on the top and the bottom, and these two top and the bottom, now that even the orders are different, we have now common denominator, right? Common denominator, just like that. Well, now that we have the common denominator, we can combine, right? So let me write x plus 1, x minus 1, and x plus 2. And this I'm going to write here, but I'm going to expand it. I'm going to skip one step. So I'm going to expand it. So it'll be x squared minus x. That will come from this. Right? So this becomes this. Plus. That plus is this plus. That plus. Now I'm going to expand it. I'm going to write it here. So 2x times x, 2x squared, 2x times 2, 4x, negative 3 times x, negative 3x, negative 3 times 2, negative 6. Just like this. Okay. Now all we need to do is combine all the like terms. So denominators, no change. Plus 2. Numerator, we have x squared, 2x squared, so it'll be 3x squared. Well, once I dealt with this second power, I usually just cross it out just to, make sure that I don't make any mistake. Negative 1, positive 3, and negative 3. Oh, these are all cancels out. So that cancels with all this, right? So no x terms. What about this? Well, that's going to be negative 6. It's like that. Okay. So this example right here, right at the end, we reduce down to this. Well, you can also, missing one. We write this because we have 3 in common. Factor out the 3, then x squared minus 2. It becomes something like this. It becomes something like this. So this is going to be our answer, and we also should have x cannot be equal to negative 1, x cannot be equal to 1, x cannot be equal to negative 2, right, from these 3. Okay, any question? Well, you can't really ask, right? All right.